When we talk about the concept of electrical charge, we're talking about how many electrons are in one area at any one moment in an actual circuit. Okay, that's a lot of electrons. 1 coulomb, which is the unit that we actually use to represent electrical charge, has a tremendous amount of electrons in it. 6.25 times 10 to the 18 electrons. That's a lot of electrons. Okay? And why we need to know this kind of stuff, when we start talking about actual circuits, all right, we're going to start drawing out circuits. We're going to start learning about the different components in a circuit, or the parts or objects that go into making a circuit. Okay? We know that static electricity is basically the exchange of electrons between two objects. Okay? And when an object takes electrons from another object or gives up its electrons, it ceases to be neutral. It becomes charged. We know that there's 3 different ways to charge an object. Okay, we can charge by friction. We can charge through conduction. And we can charge through induction. Okay, these 3 are for static electricity. Okay, now, static electricity through friction involves rubbing together, where one of those 2 substances, doesn't matter what they are, unless the 2 substances are identical. So let's say I'm rubbing wool on wool, okay? Then we won't necessarily have an exchange of electrons. But if I'm rubbing 2 different substances on one another, one of those 2 substances will always be an electron taker, and one will always be an electron giver. If I give away my electrons, I'm going to have less electrons and more protons. So if I'm an electron giver, then what will my overall charge be once I've given away my electrons? I will have an overall positive, okay, that's shorthand for positive, charge, right? I'll have more protons in me than electrons, making me have a plus charge, okay? If I am an electron taker, then that means I'm going to be taking electrons from something else. So am I going to have more electrons or less than protons? If I take electrons from someone else, I'm going to have more electrons. So if I have more electrons than protons, what will my overall charge be? I will have an overall negative charge. Now, if I am charged through friction, that is a rubbing, okay? It's when, and it doesn't necessarily have to be when rubbing occurs. It can be when things come into contact with one another. Okay, if I bang into something, if it's a windy day outside, all right, and I go outside, it's a cold, windy day, I go outside, that wind is hitting me, well, all of those little air particles, okay, the different gases that are in the air are actually colliding with me, and they're rubbing up against me when they hit me. So that will cause me to have more of a static charge. Okay, that is a form of friction. Friction is not just rubbing up against one another. It's when 2 things come into contact with one another. Okay, at very high speeds. All right? What is conduction? Does anybody remember? Conduction occurs, okay, so for friction, one will become positive and negative, right? One always becomes overall positive. One will always become negative, right? For conduction, if one is neutral and another one is negative and it touches it, it will give it some of its charge. So then they overall become both negative as a result, right? Whereas induction is the only one that has no touching. Induction is the one where something that is charged comes close to something that is neutral, and it causes the neutral object to rearrange its positives and negatives inside it so that the opposite of whatever is charged is closer to whatever is charged. If you remember with the electroscope, I charged a plastic rod and I would bring it close to that metal ball without touching it, and it would cause the actual little metal foils to move away. So it would actually cause the electrons to realign themselves and the protons to realign themselves. And as soon as that was removed, it goes back to being a big jumbled mess. Okay? So this is where we end up having all of our negatives on one side and all of our positives lining up opposite, right? So those are our three forms of charging an object. Okay, and all of this states back to the number of electrons and the number a number of electrons that are being given up by something and taken by something else. That's for static electricity. Dynamic electricity is a little bit different. In dynamic electricity, we don't have charges being exchanged between two individual objects. We actually have the movement of electrons through electrically conductive material, mostly metal, different types of metal. Okay? So here we have an example, a really crude example of a metal wire. All right? And what ends up happening here is that all of these actual chunks of metal here, okay, because one wire ends up having, it's basically the melting of many atomic, or well, particles, I guess, atoms of that particular element. So if I have copper wire, which a lot of electrical wire is made out of copper, and it's a metal, if I have copper wire, yes, it's a long string of copper, but that's actually a lot of individual atoms all stuck together to form a wire. Okay, and what ends up happening in this is that if we pretend that these are all different little atoms, I'm going to draw all these little circles, and let's assume there's way more than the ones I'm actually drawing. Okay, every one of these is actually pointed in a different direction. Okay, it wants to move in a different direction. Okay, look at how chaotic that looks. That looks like a mess. Everybody's going which way. Okay, it's like a bunch of ants scurrying away in all kinds of directions to get away from whatever's causing them to kind of flee an area. If you've ever walked along and you've seen sugar or some kind of something sweet or food-like on the ground and you've seen a lot of ants on it, okay, and, for some reason, something causes them to disperse, they all go in every which direction. It's total chaos. As soon as we actually turn electricity on and we cause electricity to actually flow through metal, what it ends up doing is it takes all of these arrows here and it points them all in the same direction. So if I've got my wire down here, which is the same sort of thing, every one of these little circles ends up pointing in this direction and ends up being moved from object to object or particle to particle in the same direction. Okay, you can see an image of that on page 150 of your text. And this is what we mean by dynamic electricity. Dynamic electricity takes electrical charges within substances, because you and I both know that a metallic wire is made up of individual atoms of that metal. A lot of individual atoms. And let's say it's something like copper. If I look back, I see that copper has an atomic number of 29, which means it's got 29 electrons in every atom of copper. Okay? So when I actually turn when I give electricity to an actual metal wire, I'm causing all of these individual atoms to push their electrons from one atom to the next. Electrons are actually moving along in a single file almost. Okay, it's like a big conga line of electrons that are moving through this actual circuit. All right? And that is what defines dynamic electricity. Dynamic electricity, when something is dynamic, it means it's energetic. Okay, it's lively. All right, if you are a dynamic speaker, you speak with a lot of enthusiasm and you put a lot of emphasis on things, and people are interested in what you have to say, and they like coming to listen to you speak. Well, dynamic electricity has a lot more going on to it than static electricity. Static electricity, the electrons are just exchanging from one object to another. Dynamic electricity has the electrons moving throughout an actual path that as long as there is actual electricity being inputted to it, it's causing the electrons to jump from one object to another, one atom to another. And because they do that, it's going to allow, let's say you've got a power source here. Okay, let's call this a Duracell battery where you've got the positive and the negative. So this is your negative and your positive. You've got a wire leaving here. Okay. Your wire is leaving here and it's coming back into here. And then right here, you've got this object here. And I'm going to get back to the whole concept of symbols in a second. Okay. Now, what ends up happening here, the battery in this case is the power supply. It gives off electrons. Okay, batteries have, and you know what a battery looks like. Okay, it can be anything from the batteries that go into your calculators to different kinds of batteries. Maybe your cell phone has a battery, your camera has a battery. Smoke detectors have batteries. Our electrical conductivity apparatuses that we used in our last lab have batteries in them. Okay, and as long as there is a loop here from both sides of the battery, electrons that are all in here, that are living in here and are installed in there when they make the battery, as soon as there's a loop here, what ends up happening is this guy here, the electrical current will actually leave here and go in this direction, and electrons will move, and then they'll actually go through this object, which is a light bulb, this symbol for a light bulb. We'll get to this in a minute. And what ends up happening here is it causes this guy to light up. Okay, and then the electrons pass through it and just keep on their merry way, and they go right back to the battery. And as long as there is this circuit, this loop, okay, this actual loop of exchange of electrons, then objects that need electricity to actually work will actually be able to work. Okay? A circuit is named that because it's a loop. If you do circuit training in phys ed or at the gym, you're basically doing a different loop of exercises, right? You're starting here, you're moving to here, you're moving to here, you're moving to there, then you're going to work on the legs, then you're going to work on your back, then your arms, and then you're done. Right? That's the concept of a circuit. It's nothing more than a loop. So when we talk about dynamic electricity, we're talking about a loop. We're talking about something that has power in it, that gives off its power through something metallic, that goes through a loop and it gets back to the power supply. Does that make sense? Okay?